All right, folks, it's Bass Action back in action here. In this video, we're going to go through the first example of our coordinate geometry, and that's how to write the equation for a perpendicular bisector. Now, a couple things I want you to notice here is I've actually written out our steps in words, but it is very crucial that you spend some time thinking again about why these steps make sense and how we're going through the processes to get them. You do need to know your formulas very, very well, or you will struggle in this. Okay, I've done part of the step one on our equation for perpendicular bisector right off the bat, and that I've already plotted my points. We're going to plot the points to give ourselves a good visual of what's happening. If you didn't have a nice perfect grid, all that would matter is that your point should be in the general proper quadrant. It doesn't have to be to scale or anything like that. It just needs to be generally in the right place. You wouldn't want to spend time to make them super precise if you didn't have a grid. Now, the second part of this first step is to find the slope and the midpoint. Okay, we have to remember that slope is going to be our rise over run. So we're going to go ahead and we're going to calculate our slope, and we're going to always make sure that we're labeling our work. So our slope says it's the change in the y, meaning what is the difference between these y values. So you could certainly write that down, or you could do it in your head, but what we're technically doing is, let's say, a 3 minus a -5, which is a plus, and then a -4 minus an 8. So that's going to give me an 8 over a -12. I can see that that slope is falling. It's negative, just like I would have wanted. And then I'm going to reduce that. We always reduce our fractions. And I reduce that fraction to get a -2/3. Now, when I go to write the perpendicular bisector, I'm actually going to need the perpendicular slope. So I'm going to give myself a reminder here that my perpendicular slope will be the opposite reciprocal, or in other words, a 3/2. That's the one that I'll be using in step 2. I also need to find my midpoint. Remember, your midpoint is simply your middle point. It is going to be an average of the x values and an average of the y values. So that means I'm going to add these two x values together. So an 8 plus the -4 is going to be a 4. I'm going to skip a little bit here. So an 8 plus the -4 is 4. I need to divide that because it's an average. And then I'm also going to do a -5 plus the 3, and -5 plus 3 is a -2. You could certainly write down more if you wanted, but the key is that you do need to remember to divide by 2. That's going to give me a new midpoint of a 2, -1. This slope and this point will be the values that I will use to write the equation of the line in step 2. Now, the next thing, because it's going to go through a midpoint and be perpendicular, so that's the two things that we needed. Now, we're going to use our point slope form of a line, and this is very crucial. So if you've used the B technique where you find the y-intercept for your lines, I do not want you using that. Our point slope form says we're going to do y minus our y coordinate, so that's going to become a y plus 1. Then I'm going to take that slope, that perpendicular slope I wanted, and then times x minus the y coordinate. Then I'm going to go ahead and solve this for y. I'm going to distribute that 3/2, so I have a 3/2 x. When I distribute that 3/2 to the 2, 3/2 times 2 is just a -3. And then I'm going to subtract that 1 from the other side. So my final answer for the perpendicular bisector is 3/2 x minus 4. And if you actually graph that line, if we came over here and we graphed that line, a y-intercept of a -4, and then I'm going to go up 3 and over 1. And I start to, if I graph in that line, up 3 over 2 I meant to say. As soon as I started graphing it, I knew I had misspoken. If I graph in that line, the y-intercept of -4 and a slope of 3/2, sure enough, it goes through that midpoint, and it definitely looks like it's perpendicular. So we can feel good about our answer.